So up to now, we have seen the three types of graphical displays that we can do for quantitative variables. And one of those graphical displays was a histogram. So what we want to look at in this video is the shape, or how can I describe the various shapes of histograms. With that description, we're going to be able to describe the shape. We start to get an understanding of where the center of the data is occurring based on that shape, and then we can also talk about how spread out the data is just based on the shape. The first one we want to look at is called a uniform distribution. And when we look at this uniform distribution, you'll start to notice that all of the heights of our bars are equal. So that is a type of characteristic. Now, this is a computer generated distribution here. In the real world, it may not always line up that they're just all equal here, but they should be relatively the same height. Another characteristic on a uniform distribution is that it's symmetric. So imagine that I have a line drawn here in the center of my graph. And if I were to fold the graph over that line, then it would be the same when I folded it over. So that's what I mean when we're talking about a symmetric distribution. Now, an example of a uniform distribution could be if I wanted to, let's say, take one dice or a die, and that is a six-sided die, let's say, and I roll the die. Each time I roll the die, I'm equally likely to get a 1 or a 2 or a 3 or any of the other remaining sides on that dice. And so what we would have is the probability for each of those dice, or each of those numbers, would be the same. And that's what a distribution of that type of a rolling would look like, a uniform distribution where every outcome is going to be the same. So the second type of a distribution we have is what's called a bell-shaped distribution. A bell-shaped, or as I'll later on start calling this, a normal distribution. And in our bell-shaped distribution, notice that we have in the center of our data, right here, we have a single peak. And the taller the bars, where we learned the height of our bars indicates the count or the frequency of what's contained inside. So the taller our bars are is going to indicate that the more data is there. And then the shorter the bars indicates fewer data. So what we're looking at in a bell-shaped distribution is that the majority of our data is occurring right here in the center. And as I move out to the left of the center, I get less and less data. And then as I move out to the right of the center, I get less and less data. Once again, if I were to imagine a line drawn in the center of my histogram, then if I folded the graph along that line, you would be able to tell it's symmetric. So it would be the same on both sides of that fold. Another idea when I look at my histograms is to see if I can imagine just sketching a curve along that histogram to kind of get an idea of what the general shape of the histogram is going to look like. And so here I've kind of sketched a smooth curve on top of my histogram, and that's what I can think of when I think of a normal distribution or a bell-shaped distribution. Now, let me get rid of those lines for a second, and let's talk about an example of a normal distribution or a bell-shaped distribution. One example I can think of would be our grade distribution. So if you think about the 5-letter grades, A, B, C, D, F, and if you've ever heard of someone grading on a bell curve, this is what they're talking about. In general, the letter grade C is what we would say is an average grade. And so that's what we would have in the middle of our graph. So the majority of the grades, whatever we're looking at, would be C. And then as I move to the left of the graph, I would have some grades which would be represented by a B score, and some grades which would be represented by D. Now, there are not as many B's and D scores as there are the C's, but you can see we're getting less and less values. That leaves us then with our A scores as well as our F scores. So we would have even fewer A grades and fewer F grades than the previous BDs as well as the previous C. And that's kind of an example of a normal or a bell-shaped distribution using grade distribution. The third type of a distribution that we want to identify is called skewed right. When we think about a skewed right distribution, I like to look at where the tail is headed. So again, if I were to come over here and sketch a curve on top of this histogram, the tail is moving off to the right, and that is the name that I'm going to associate with this type of a distribution. Notice that on a skewed right distribution, the majority of our data, so a lot of our data, is occurring over here, just kind of to the left of the center. And we have less and less data that is occurring over here to the right of the center. So let me get rid of those lines right there, and we'll talk for just a second about an example of a skewed right distribution. Housing prices. So average or median price of a home in your city. When we think of that, we would have some houses that are going to be lower in cost. And then as I move here on my graph, I'm going to finally get to maybe a peak cost for housing. And then I'm going to start having higher costs, but less homes are going to cost in that higher range until I get out here to fewer and fewer homes, which are going to be like in the $1 million range, let's say. So this is an example. Housing prices would be an example of a skewed right distribution, where on the left over here, we have kind of the majority maybe of our home prices. More homes are going to be at that price level. And then as we get more and more expensive, we have fewer and fewer homes that we would encounter at that price. So if we have a skewed right distribution, then that's going to imply that we also have a skewed left distribution. And just like in a skewed right distribution, if I can make a curve on top of this and follow the tail to the left, that's going to be my skewed left distribution. Similarly to the skewed right, in a skewed left distribution, the majority of the data that we're looking at is moved to the right of our center, and fewer data, right, smaller, shorter bars means fewer data is going to be to the left. An example of a skewed left distribution could be the age at retirement. So if you think about how old you are when you retire, right, there's fewer people that are going to retire at a younger age until we get to the general age of retirement, say right here. And then once we go past that age, we have older people, but fewer of them are going to be retiring. So skewed left, age of retirement would be an example for skewed left. Here are 4 of the 5 shapes that we are talking about that we need to make sure that we understand and memorize: uniform, bell, skewed right, and skewed left. So now let's look at the 5th type of distribution we could encounter, although not quite as much, but it's considered a bimodal distribution. You'll notice here that in my histogram that we're looking at, I have 2 distinct peaks that are being shown. So if I were to sketch my curve up here, I have one curve here, dips down a little, I have another curve here, and then moves on. This is why it's called bimodal, as opposed to the previous slides, which showed us a unimodal distribution. So bimodal distribution has 2 distinct peaks, and it is, as well as the previous slide, it's going to be considered symmetric. So if I were to fold it in half, it would roughly line up on both sides of that fold. An example of a bimodal distribution you can see here is going to be heights by gender. So if I grouped everybody's height together, both males and females, it would be a bimodal distribution because you have females who have an average height over here, and you have males who are going to be taller, but they have an average height over here. Now, if I were to graph only the males, which would be here in blue, you can see that that would be a bell-shaped curve, as well as female heights only in pink would be a bell-shaped curve. But if I graph both of the genders together, you end up with a bimodal distribution. So heights by gender or heights would be a bimodal distribution. Remember that it's considered symmetric. And our other distributions over here that are symmetric are considered uniform as well as bell-shaped. So these are the 5 distribution shapes that you need to be understand and memorizing.